Good afternoon, friends. We will start now today's physics class. This is Professor Chaubey's physics class under the heading Physics Made Simplest for CBSE, NEET and JEE students. I will do today now some problems of photoelectric effect. Problems of photoelectric effect. I have just written one. Calculate the energy of a photon in eV whose wavelength is this 4000 angstrom. So find out the energy of photon. Well, how to calculate energy of photon? Energy of photon, you know, from the quantum theory, energy of photon means how energy related with the frequency. Energy photon is h nu, where h is the Planck constant and nu is the frequency of the photon. So h nu, or you can write in terms of velocity of light and the wavelength, it is h c over lambda. Lambda is given 4000 angstrom. This is the wavelength lambda. So you can use lambda, you can use c, and you can find out the, you see, h is the Planck constant. How much? Exact value 6.62. 6.62 into 10 to the power minus 34 joules. And then at the next we have, say, C. C is equal to 3 into 10 to the power 8 meters per second. And lambda is given, lambda how much? 4000 angstrom. That means lambda is equal to 4 into 10 to the power minus 7 meter. So these are the data. Now you can find out the energy E. E is equal to hc over lambda. So now substitute the value of all constants, that is 6.62 into 10 to the power minus 34. That is the h. What else? Into c, 3 into 10 to the power 8. And what else? Divide by, yes, h over lambda. So lambda is 4000 angstrom, means 4 into 10 to the power minus 7 meter. Well, you calculate this answer, multiply. I get 4.96. 4.96 into 10 to the power minus 19, and the energy units are joules. But the answer want in eV. So you convert this joules into eV. Well, we know that we can get this all 4.96 into 10 to the power minus 19 divided by the eV and joules relation. That is 1.6 into 10 to the power minus 19. So this will be now in eV. Obviously this will be 3.1 eV. So this is the energy of photon whose wavelength is in angstrom 4000. Okay? So simple. Just substitute the value of constants h and c and lambda. Now what else? We have, what is the frequency of a photon whose energy is 75 eV? What is the frequency of photon whose energy is 75 electron volt. So find out the frequency. The energy is given. Just we have done just now. Similarly, E is equal to h nu. So frequency, they are asking frequency. H is given, E is given. E is 75 eV. So just substitute. E is equal to 75 eV, and you can convert this into proper unit of energy, that is the joules. So 75 into 1.6 into 10 to the power minus 19. This is now joules. What else? You have, say, H. H is equal to 6.62 into 10 to the power minus 34 joules second. What else? Yeah. So find out the frequency. That's the new frequency, new E over H. That is, say, 75 into 1.6 into 10 to the power minus 19. E over H, 6.62 into 10 to the power minus 34. Well, now solve this. You will get the answer very easily. So that will be around 18 into 10 to the power 15. Hertz. That is the frequency. Thus you can see this will come 10 to the power plus 34. Just solve, nothing else. So this is so simple. Means you have basic equation of energy from the quantum theory. E equal to h nu. Just nu is the photon frequency, h is the Planck constant. You remember that where Planck constant is there, it becomes quantum. Classicals are non-H. All formula or every business without H is classical. When H comes, it becomes quantum. Okay, I will solve some other problem also. Let us see. Another problem is find the number of photons. Find the number of photons emitted per second. Find the number of photons emitted per second. Find the number of photons emitted by a 25 watt source. By a 25 watt source of light, monochromatic light, of light of 6000 angstrom wavelength. Here we have to find the number of photons emitted per second. What the intensity, where power wattage is given. So this is also not very difficult. What we should do? Energy of photon you have to get is hco lambda. So you can get energy by just putting the values. E is equal to Hc 6.62 10 to the power minus 34 3 into 10 to the power 8. Lambda is 6000 angstrom, so 6 into 10 to the power minus 7. This E will be, you calculate this, the answer of this will be 3.31 into 10 to the power minus 19 joules. This is the energy. Now, number of photons emitted per second. Number of photons emitted per second. How to get number of photons emitted per second? Energy emitted per second divide energy 1 photon. Energy emitted per second divided by energy of 1 photon. That will give you total energy divided by energy of 1. So number of photons. So energy emitted per second and number of, so that is from the watt, from the power. That is the energy emitted per second is 25 watt. So that is how much? 25 watt is energy emitted, 1 watt, 25 watt source, like this, 25 watt. And the energy of 1 photon is 3.31 10 to the power minus 90. So this will give you the number of 7.55 into 10 to the power 19. That is the number of photons. Very easy. This is the answer. Number of, because this is the energy in watt, that is joules per second. So that is, and divide by the, so this is the energy 25. You divide this 3.31 energy of 1 photon, 3.31 10 to the power minus 90. So divide by this energy. So nice. Now let us see. You know watt is divided by joule second divided by second. So joules. Now we have some other, let us see, some other problem. What we have, X-ray tube produces, X-ray tube producer X-ray tube producer continuous spectrum of radiation, continuous spectrum of radiations, continuous spectrum of radiations with a short wavelength and 0.45. This is the end, short wavelength end. What is the maximum energy of photon? What is the maximum energy of photon? An X-ray produces continuous spectrum of radiation with a short wavelength 0.45. Because energy is E is equal to hc over lambda. Maximum energy will be when lambda is minimum. So lambda minimum given here. So that what is the energy of this wavelength? H 6.62 10 to the power minus 34, C 3 into 10 to the power 8 divided by lambda. Lambda minimum, its minimum value is 0.45 10 to the power minus 10. 45 into 10 to the power minus 10, that is meter. Now you solve this, you will get E max. The energy maximum is 4.413. It is 4.413 into 10 to the power minus 15. Joules. Or convert into 4.413 into 10 to the power minus 15 divided by 1.69 into 10 to the power minus 19. 1.6, why 9? 1.6, sufficient. And this is how much? 27.5 into 10 to the power 3 eV, or that will be 27.5 keV, kilo electron volt. So this is because wavelength is minimum, the energy will be maximum. So energy of the radiation which is maximum is 27.5 keV. When the X-ray source has the wavelength minimum 0.45 angstrom. So this is the answer. Very easy, just you have to substitute the values in the formula and nothing else. Okay, so now some more problems. Let us have some more problems. Say, okay, find the frequency of light. Find the frequency of light. Which light? Ejected from. Find the frequency of light. Find the frequency of light which ejects electrons from a metal surface. What is the frequency of light which ejects protons from That is the photoelectric effect. For metal surface, it is ejecting photons fully stopped by a retarding potential. Fully stopped by a retarding potential. Fully stopped by a retarding potential. How much potential? 3 volt. While 3 volt potential stops ejected electron completely. The threshold frequency is the threshold frequency is 6.66 into 6 into 10 to the power 14 hertz. So this is the threshold frequency, means above this frequency a photoelectric effect takes place, or this will give you work function of the metal surface. That is easy. So what we have? We have the equation we know from photoelectric effect. Energy of photoelectron, K shell, is how much energy? H nu, which is the energy of the photon, minus work function of the metal surface, W. So that is the energy units is the EB, and so you can find out H nu energy here, and this is a EK, that is the electron current energy. So this we cannot. That is EK is equal to H nu minus H nu naught. This is a work function W, where nu naught is the frequency for the starting, that is the threshold frequency. That will give you H nu is equal to EK plus H nu naught. That is, you will get nu is equal to, now from this, EK plus H nu naught, H nu. And EK is how much? Threshold frequency is given, so you can find out this. Nu naught this. Nu naught is 6 into 10 to the power 14. Nu naught is given here. So from this you can see that, now what is the value? Unknown. What is the value? You want to get nu. What is the nu? Well, EK plus H nu naught divided by H is equal to nu. They ask find the frequency of light. So nu is equal to EK plus H nu naught over H. That you can find out. How we can find out now? Well, we can find out very easily now. You substitute the value of H and say, what is the EK? Electron energy. How you will get EK? EK you can get the potential. The stopping potential is 3 volt. So stopping potential. Three volt. So energy EK of electron will be EB. E is 1.6 into 10 to the power minus 19, and V is 3 volt. So this becomes EK. Now nu will be 1.6 into 10 to the power minus 19 into 3 plus H nu naught. This is nu naught. 6.62 into 10 to the power minus 34 into 6 into 10 to the power 14 divided by H. 6.62 into 10 to the power minus 34. Well, you solve this. Very easy. You will get the value answer. 1.324. Nu will be 1.324 into 10 to the power 15 hertz. This is the answer from, just you solve this, you can solve this, you can cancel this here, this will be remaining, and here you can just see this. So just a small work, calculation, just find out frequency. That here you are given stopping potential so that you can get the energy of the electrons coming out from the metal surface. Because energy is EB, where V is the potential to stop electron, that gives the energy. Energy is E into V, charge into voltage. So simple. Okay, we will do one or two more problems and then we will take again rest. This is our continuous session today, and let us see how much we can do. So let us have what we should do. Some problems I want to do some other type of problem from the let us do some other type of problem. Some problems of the discussion type can we do? We have some idea, or anything else you can do. I don't know what type of problems now we can do. Some problems of the discussion type, or I want to do some okay, some problems of other type, say photons of frequency F incident on a metal surface, threshold frequency F0, the maximum kinetic energy of emitted photons is. The maximum kinetic energy of photon. The maximum kinetic energy of photon, where F is frequency, F0 is threshold frequency, so F0 is given. Find out the maximum energy. I have answers. Find out that answer. H plus F0. H F plus F0. Second answer. HF. Third answer. HF0 And fourth answer, H F minus F naught. This is the problem. Find out the maximum kinetic energy, that is of the photon, when photon is emitted. With the energy, the photoelectric effect takes place. So the frequency is F, and F naught is the threshold frequency for that metal. The electrons coming out will have maximum kinetic energy, whether this first or second or third or fourth. So let us judge. First, if we take answer from the common sense, there is no need of any mathematics. Common sense. What is F plus F naught into H? So this is simply H frequency, H in U or H, F plus F naught. Here we are adding the two frequency, threshold frequency plus the frequency which is ejecting the electron. So this addition of frequency, this energy becomes more than the applied energy. This is not possible. That energy becomes what energy, incident energy is HF. And they are asking the maximum kinetic energy of electron, maximum kinetic energy of photon. It is not possible because it will be more than what energy is frequency F. HF is the photon frequency F, incident metal this, frequency F naught, the maximum kinetic energy of emitted photoelectron. So energy of photoelectron, this was the HF was the total energy supplied to the metal plate, and then electrons coming out. So this is the energy, incident energy, and this cannot be energy of the photon, because energy you are putting on the plate, ejected electron will have definitely less energy than the incident photon. So this is the incident photon energy. This was the incident photon energy plus threshold energy, much more. So both are not possible. This is HF naught. This is the frequency of threshold photon. So threshold energy. So this is the energy required to remove the electron. This cannot be the energy of the electron. This is the frequency applied, this is the threshold. So above this frequency, photoelectric effect takes place. So this is the energy lesser than the energy supplied. And this was the energy HF naught which is required to remove work function. So this is the correct answer. That this is the work function H1, this is the photon energy HF, and you are applying on the metal plate. So this is ejecting electron. So HF naught is used to remove the electron, and hence the kinetic energy, maximum kinetic energy of the ejected electron will be HF minus F naught, and not HF naught or HF. No, it is not correct. So friends, thank you very much for listening me. We will again take a break here.